Okay, so we will discuss October-November 2022 paper 3-2 in this video. So let's start with question number 1. We are giving the equation that involve the indices, and then they want us to give the answer in the form of ln A divided by ln B, where the A and B are integers. Alright, so they want to solve this particular equation, and our answer should be in this pattern. Alright. Okay, so when we are having all the equations are with indices, there are many ways for us to solve it. Some will straight away take ln or log at the early stage. Alright, so for me, what I suggest is I will split all the power out. So as an example, 2 power 3x, I can make it become 2 power 3 and then with the x outside. And then multiply with 2 power negative 1. I'm having 5. Multiply with 3 power negative 1. Multiply with 3 power negative x. So if I try to simplify it, I'm having 2 power 3, which is a 8. So I'm having 8 power x divided by 2 power negative 1 is a 2. 5 times 3, I get 15. And then at the denominator, I'm having 3 power x. Okay, and next one, I will want to group all the terms with the power x to one side. So I will multiply the 3x up. Since both of them are having the same power, which is x, right? So you can multiply the number together, where we are having 8 times 3 is 24 power x. And I'm having 30. When I successfully group all the x at one side, then only I will take ln at this stage. So I will take ln both sides, where it will become x ln 24 equals to ln 30. And from here, the value of x should be equals to ln 30 divided by ln 24. Okay, so basically this is how we actually answer this question. There are many other methods, alright, but for me, I will try to group all the x together first at one side, then only I will take ln both sides. Okay, so question number 2. We have a polynomial with a constant a and then denoted by px. It is given that 2x plus 3 is a factor of px. So the keyword is factor here. That means we can use a factor theorem. And to use a factor theorem, the value of x that we should substitute should be x equals to negative 3 over 2, right? So according to factor theorem, if I'm having px equals to 2x power 3 minus x squared plus a, according to factor theorem, if I substitute the value x equals to negative 3 over 2, then my polynomial will get a 0. Okay, so this is basically the factor theorem that we have. Therefore, we have to substitute all the value of x with negative 3 over 2. Okay, so if we try to further simplify all the terms here, we'll get a equals to 9. Okay, so this is how we get the value for a. So we are using the factor theorem here. Alright, and then let's continue to part number B. So when a has this value, they want us to solve the inequality for px smaller than 0. Okay, so before we can solve any inequality, right, it will be better if we can try to factorize up the polynomial become the smaller brackets. Then it will be easier for us to do the calculation later. Right, so for this original polynomial with x power 3, I will want to apply long division so that I can further factorize it into a smaller bracket. Okay, so I will apply long division now, where the polynomial is this one. There's no x, right? So I will put a 0x for a place, right, for me to write the answer. And then the divisor will be 2x plus 3, because we know that this particular divisor is also the factor. Alright, so we will start the long division. So something multiply with 2x to get 2x power 3. The something here will be x squared. So x squared multiply with 2x, I get 2x power 3. X squared multiply with 3, I'm having 3x squared. 1 minus 3, you get negative 4. Pull down all the terms on top. And now I'm thinking something multiply with 2x to get negative 4x squared. So the something here should be negative 2x. So then negative 2x multiplied with 2x, I have negative 4x squared. Negative 2x plus 3, I'm having negative 6x. And continue for the next one. Okay, so negative 4 minus negative 4 minus negative 4, I get 0, right? So 0 minus negative 6, I have 6x, then plus 9. So again, I'm looking for something multiplied with 2x to get a 6x. The something here should be a 3 lah. So I'm having 6x plus 9. Okay, so from here I know that my polynomial can be further factorized as 2x plus 3 multiplied with x squared minus 2x plus 3. So if I try to put it inside the inequality, px smaller equals to smaller than 0. So according to the long division, right, we are having these two factors for the px. Right, so for this particular quadratic factor, if I try to further factorize it, I realize that I can't factorize it into a smaller bracket. So I would like to know and would like to investigate lah. Right, so what is the shape for this quadratic factor? So I will copy 2x plus 3 first. So to understand or maybe to figure out what is the shape for the quadratic factor, basically I can apply the completing square. I will want to change it become a completing square pattern. Okay, so for the completing square, this is the term that we add and minus so that we can actually factorize or maybe rewrite the first three term become x minus 1 square. Then I'm having negative 1 plus 3. So I'm having plus 2, which is smaller than 0. Okay, so once we figure out and completing square already, right? So we will want to investigate this particular part here. Okay, for this quadratic expression, if we try to find out the vertex, right? We are having the positive coefficient for the x squared. Therefore, it should be a U shape. And then the vertex or the minimum, okay, the coordinate for the minimum will be actually 1 and 2. That means if I try to sketch the diagram out for this particular quadratic expression, it will look something like this. Okay, where this one is a value 1 and this is actually the value 2. Okay, so if you try to observe the diagram for the quadratic factor, right, or the quadratic expression, you will see that it lies above the x-axis. It always lies above the x-axis. Okay, so which means that this particular quadratic expression is always positive. Okay, so since we know that this part is always positive, right? Okay, which means this part should be always negative lah. So that negative multiplied with something positive, we should get a negative value always. Alright, which means I must ensure that my 2x plus 3 is always negative, so it will be smaller than 0. And from here, you know that if your x is smaller than negative 3 over 2, right, then you'll get a polynomial that gives you a negative value. Alright, so this is how we solve this question, inequality for px, which is smaller than 0. Question number 3, the equation of the curve is this one. And then the curve has a stationary point in the interval 0 until pi over 2. So the keyword here is stationary point. So when you see this stationary point, basically we should try to link that we are going to let the dy dx equals to 0 later, so that we can solve for the coordinate for x or maybe the y. Okay, so for this question, they want us to find the x coordinate for this point, giving your answer correct to 3 significant figures. Alright, first step, we should try to differentiate it first because we need to let dy dx equals to 0, right? According to what we see here, we are having the product of two functions. Okay, so we are having sine x multiplied with sine 2x. So these are two different functions here, okay, two brackets. To differentiate the two brackets, the product of two expressions, we need to apply product rule. And the dy dx will look something like this. You can copy the first bracket differentiate the second bracket. So when I want to differentiate the second bracket, differentiate sign, I get cos 2x. Then you need to further differentiate the 2x, you get a 2. Plus, then now, just now I copy the first bracket, differentiate the second, right? And now we should differentiate the first bracket, copy the second bracket. So differentiate the first bracket, sin x, I'm having cos. Then I copy the second bracket here. And now I try to simplify my equation. I will let dy dx equals to 0. And then for this part, I'm having 2 sin x cos 2x plus sin 2x cos x. From here, I can't factorize out anything, and I feel that if I can try to expand the sin 2x become using the double angle formula, we are having one formula for sin 2x, right? Okay, the double angle formula, sin 2x can be written as 2 sin x cos x. This formula can be get from the formula booklet, right? And for the double angle formula of sin 2x, I can make it become 2 sin x cos x. And the cos x here multiplied with the original cos x, I'm having cos square x. And when we go until this step, right, I will try to observe and see whether can I factorize out anything or not. And I realized that I can factorize out 2 sin x. Therefore, I factorize out the 2 sin x, then my expression will look something like this. Okay? Yeah. And from here, I can attempt to try to try to solve the equation. I'm having two equations here where 2 sin x equals to 0. Another equation will be cos 2x plus cos square x equals to 0. If I try to solve this part of question, this part of equation, I will get the answer which is x equals to 0. And this is actually not our coordinate for the maximum or minimum point, or for the stationary point, right? Why it is not the coordinate for the stationary point? It is because of the question stated before, the value of x should be between 0 and the pi over 2, and you can see that there's no equal sign here. That means 0 is not included in the domain given, right? Therefore, the x equals to 0 is not the answer. And now we are going to focus on this equation. To solve this equation, right, first step, we have to try to change this cos 2x become a single angle, alright? Cos 2x is a double angle formula, so we should apply some double angle formula for cos 2x so that we can change it become cos x. Cos 2x, you can use 2 cos square x minus 1. You can use 1 minus 2 sin square x, or you can use it you can change it become cos square x minus sin square x. Basically, for this equation, we will select this one, where our aim is to change our equation become everything in terms of cos x. So cos 2x, if I apply the double angle formula, 2 cos square x minus 1 plus cos square x equals to 0. From here, I'm having cos square x, 3 cos square x equals to 1, cos square x equals to 1 over 3, cos x equals to 1 over square root 3. For me, I only consider the positive value for 1 over square root 3 because the domain already stated that the x is between 0 until pi over 2, which is actually in the first quadrant. So I only consider the positive value for the first quadrant. And from here, if I take inverse cos, then I will get 0.955. Correct to 3 significant figure. Our answer should be in terms of radian because the range given just now in the question is also in terms of radian. Right, so this is how we solve question number. Okay, so question number 4, they want us to express 4 cos x minus sin x in this form, become r cos x plus alpha, where r is greater than 0, alpha is between 0 until 90 degrees. They want us to state the exact value for r and also the alpha correct to 2 decimal places. Okay, so for this question, there's a fixed formula for us to apply to find out the R and also alpha, where you need to know that the coefficient for cos x is actually the A, and then the coefficient for sin x is actually the B. Okay, and then to find out the R, the formula will be a squared plus b squared square root. So I'm having 4 squared plus -1 square square root. From here, I'll get the value for R, which is equals to square root 17. So we'll keep our answer in this form, like exact value. And to find out the alpha, since alpha should be in the first quadrant, right? If you have a look from here, 0 until 90 degrees, it should be in the first quadrant. Therefore, when we will try to find out the angle, we ignore all the negative sign. So it should be tangent inverse B over A. And the B here, I ignore the negative sign, it will become 1 divided by 4. And if I make it correct to 2 decimal places, it should be 14.04 degree, which means that our original expression can be expressed as square root 17 cos and then x plus alpha. Alright, and now we can proceed to part B. For part B, they want us to solve this equation cos 4 cos 2x sin 2x equals to 3. And then the value for x, or the domain of x, should be from 0 until 180 degrees. Okay, so if we have a look for this one, 4 cos 2x minus sin 2x, right? It is having the same pattern here, just that the x in part number A, they have changed it become 2x in part number B. Therefore, to solve this equation, I can use the result that I get in first part, where this one, okay? But in our original part 1, right, all the value here is the x, and then when we change it into the cos, into this pattern, right, square root cos x plus alpha, this is the x. But in our question, we are having 2x and 2x, therefore the x here we should also multiply it become 2x. Alright, so I write it again. I'm having square root 17 and then cos with 2x, it is not x anymore, it should be 2x, and then plus 14.04 degree equals to 3. And now I want to further solving the equation so that I can get the value for x. Okay, now we try to find out the basic angle first. Basic angle will be cos inverse 3 divided by square root 16. And according to the basic angle that we get, I'm getting 43.31 degree. Okay, and now we are going to go through the quadrant and look for the suitable answer from the suitable quadrant. Okay, what are you looking for? We are looking for the cos with a positive value. So for cos with the positive value, basically it appears in first quadrant and also the fourth quadrant, right? So all sine, tangent, and then cos. And then it is basic angle, pi minus basic angle, pi plus basic angle, 2 pi minus basic angle. Okay, then if we are looking for cos with positive value, right, we also need to know how many quadrants I need to go through. So in our question here, they are saying that x is between 0 and 180, which means first 2 quadrants only. But please don't forget that in our solution here, we are talking about 2x. So if we are having 2x, right, that means when we go through the quadrant later, it should be from 0 until 360 degrees, which means that we need to look for 4 quadrants for the final answer. Alright, okay, so now let us start. I'm looking for cos positive. Right, I'm looking for cos positive. Therefore, to get the cos positive angle, to get the cos positive quadrant, right, in the first quadrant, cos is positive. Therefore, I want to answer for the 3.31, which is the basic angle. The data here is actually a basic angle. Okay, for the second quadrant, cos is not positive, so I ignore it. For the third quadrant, cos is also not positive, so I ignore it. And for the last quadrant, cos is positive. Therefore, I want to answer from this part. And to get the answer from this part, you should take 2 pi minus the basic angle. When I take 2 pi minus the basic angle, I'm having 316.69. So for the next step, if I want to find the value for x, I should move 14.04 over become minus. So 43.31 minus 14.04. After that, I divide it by 2. And if we didn't do any careless mistake, right, the first answer that we get should be 14.6 degree. And after that, for the second answer, 316.69 minus 14.04 and then divided by 2, we should get 151.3. Therefore, for this question, we should have two answers for the x, right? Where the first one is 14.6 and then another one will be 151.3. Okay, so this is how we answer question number 4. We come to question number 4. Okay, so we are giving the equation, right? Okay, solve the equation of z squared minus 6iz minus 12 equals to 0, giving the answer in the form of x plus yi, where the x and y are real and exact. So I have the keyword exact, means that your final answer must be in surd form or maybe the pi form, right? Cannot be in the decimal number. Okay, so we are having z squared minus 6iz minus 12 equals to 0. This is actually a quadratic equation in z, but you can see that we are having a complex number, okay, the I here. Therefore, to solve this equation, we should use a quadratic equation to solve for the z, to get the z, alright? So from this equation, you know that A is the coefficient of z squared, which is a 1, B is the coefficient of z, which is negative 6i, and C is the constant term, which is negative 12. So I'm using negative B plus minus square root B squared minus 4ac, then divided by 2a. Alright, so to get the z, I try to simplify all the terms here. Negative 6i squared, I'm having 36 with I squared, and I'm having negative 36 eventually. And then I'm having plus 4 times 12, which is 48, then divided by 2. Further simplify it, I will have 12 divided by 2, and then 4 times 3, I'm having 2 square root 3 divided by 2. So if I expand my answer, I will have two answers here basically. The first one will be positive square root 3 plus 3i. Another answer will be negative square root 3 plus 3i. Therefore, we are having two roots, okay, for the equation here for the complex number z. Alright, so the first one will be square root 3 plus 3i, another one will be negative square root 3 plus 3i. So we keep it in the exact form. Right? Okay, so let's proceed to question number B. Question number B is here. Okay, so on the sketch of an arc diagram, right, with origin O, they want us to show point A and point B that representing the roots of the equation in part A. So let's say I let roots number 1. Root number 1 is equal to square root 3 plus 3i, and then root number 2 is negative square root 3 plus 3i. Okay, so if I want to sketch it on the Argand diagram, how will it look like? Okay, so I'm having the real axis and imaginary axis, and then square root 3. Square root 3, if you press calculator, it will be something like 1.7 something like. Then 3 should be higher, right? So I will label this as square root 3, and then 3 will be much more higher, which is 3 here. And then for the x, I'm having negative square root 3 as well. So negative square root 3 plus 3i, the point will be here, and this can be our exact one. Or maybe you can write as A, they want us to label it as A, B, right? So this is point A, and then maybe this one is point B, where we are having negative 3, negative square root 3 plus 3i. So our B is here. Okay, so these are the two roots that we have. on the argon diagram. And then if you want to see the O, so this is the origin O, this is the root number 2, and this is the root number 1. Okay, then let us proceed to part number C. For part number C, they want us to find the exact modulus and also the argument of each root. So again, highlight the keyword exact. So let us start now. We are having Z1 again. Just to recall back, square root 3 plus 3i. And then the Z2 is equals to negative square root 3 plus 3i. So to get the modulus and argument for these two roots, right? So the modulus Z1 will be what? Will be square root of square root 3 square plus 3 square, where you're having square root 9 plus 3, which is actually a 12. And then if you want to further simplify it, it will be 2 square root 3. So this is my modulus for root number 1 in the exact form, right? Then for argument part, to get the argument for Z1, if you try to observe this complex number, it is actually located in the first quadrant. To get an angle in the first quadrant, it is the basic angle where we are having tangent inverse 3 over square root 3. Okay, and then you will get the answer, which is 60 degree, and we'll put it in pi over 3. Okay, so this is the argument for root number 1. And now we proceed to modulus for root number 2. Okay, so for the modulus of root number 2, basically the idea is still the same. I'm having a square plus b square square root. If I try to simplify, I get the same value, which is square root 12, and then I'm having 2 square root 3. So the modulus for root number 2 is actually 2 square root 3 as well. So you can observe and see that basically they are the same, right? With the modulus for both roots are the same actually. And now we are going to get the argument for Z2. If you want to get the argument for Z2, if you have to look for the coordinate here, negative square root 3 plus 3i, you know that they are in the second quadrant. Okay, so to get any angle, right, from the second quadrant, you need to take 180 degree or pi minus the basic angle. Okay, so let's start. Pi minus the basic angle. So to get the basic angle, it is tangent inverse b over a without the negative sign. So it will be pi minus pi over 3. Therefore, we will get 2 pi over 3 for the argument of Z2. Okay, and continue to part number D. They want us to show that the triangle OAB is equilateral. To show that the triangle OAB is equilateral, let's have a look again for our diagram here. Where is the triangle OAB? So basically the triangle OAB will be this one. Okay, so this is the triangle OAB. And then from the part C just now, when we calculate the modulus and also the argument for both root, right? We know that A is actually our Z1, and we know that the length for OA should be 2 square root 3, which is the modulus of Z1. And then the length for OB is also 2 square root 3, which is the modulus of Z2. And now to prove that this is an equilateral triangle, I need to find out the distance between AB. To get the distance between AB, right, since we know that they're having the same height at the same level, so we are not going to consider the y coordinate. We will only consider the x coordinate. So from A to the y-axis here, it will be square root 3 unit. And then from the y-axis to B is also another square root 3 unit, right? So the length for AB will be square root 3 plus square root 3, which is 2 square root 3. So from here you can see that all the three sides here are having the same length, which is the 2 square root 3. And therefore from there we can prove that the triangle OAB is a right angle triangle, right? So if you want to write it out, you can say that OA is equals to OB, which is equals to the modulus of Z1 or the modulus of Z2, and they are 2 square root 3. And then to get the length for AB, basically you are taking square root 3 plus square root 3, which is also 2 square root 3. So from here, since the three sides of the three sides are having the same length, right? Therefore, you can tell them that OAB is an equilateral triangle. Okay, so before you can make this conclusion, definitely you need to show uh, some reason. How can you actually conclude that this triangle OAB is equilateral triangle? Right? So this is how we answer question number 5. Question number 6, we are having the position vector for A, B, and C. Okay, so you can see here, and then by using a scalar product, find the cosine of angle BAC. Right, so to find out the cosine for angle BAC, basically they are something like this. Okay, so let's say I'm having BAC, and then this is the angle that we want to find, the cos angle that we want to find. And then when we want to use the scalar product, we have to ensure that the vector that we are using should be both going up from the point that form the angle. So we should have the vector AB and AC before we can get the angle or the cosine of angle. Alright, so first we try to find out AB first. So AB will be AO plus OB, where it should be something like OA. OA so means that I have to multiply a negative into this vector, -1, -3, and -1, plus OB. So plus OB will be 3, 1, 2. And I'm having 2, -2, and also 1. Of course, we also need to find out AC. AC will be AO plus OC. And then from here, we are having -1, -3, and also -1, plus 5, 3, and -2. Okay, so if I simplify it, we are having 4, 0, and -3. Okay, so after I have the vector AB and AC already, so we are going to use the scalar product to find the cosine of angle BAC. The general formula will be AB dot AC equals to the modulus AB modulus AC, and then I assume that the angle is theta, so I'm having cos theta. Right, so AB dot is AC, sorry. AB dot AC equals to the modulus of AB, we are having 2 square plus -2 square plus 1 square. And then for the modulus of AC, we are having 4 square plus -3 square. Then with value cos theta. Okay, so to get the dot product for AB and AC, you multiply the x with x component, y with y, and also z with z, and you add them together. So 4 times 2 is 8. -2 times 0, you get a 0. Then 1 times 3, you get a 5. So we have, 1 times -3, you have -3, right? So it will become 8 plus -3, which is a 5 later. And then simplify all the constant term here. All the modulus here. We are having square root 9 and also square root 25. Then cos theta. Okay. Then simplify again. 5 equals to 3 times 5 cos theta. And therefore, we can get the value for cos theta, which is 5 divided by 3 times 5, and our final answer will be 1 over 3 after I simplify the fraction. So for this question, they're asking for the cosine of the angle BAC. Therefore, our answer should be in this formula, cos theta equals to 1 over 3. Okay, then now we can proceed to the part B of question number 6. For part B of question number 6, they want us to find the area of triangle BAC. Give your answer in a simplified exact form again. Like what we mentioned just now, if we want to get the area for BAC, right, this is a triangle BAC, and then we can actually use the formula where to find out the area of the triangle, you can use half AB sine C. That's a general equation that you can use. So you can use this side, and also this particular angle, okay, in the formula for the area to get the answer for the area. Alright, so we need the side, the length for AB, the length of AC, and then sine the angle inside sine theta. Okay, so we will start and the puppy. Alright, so I want to find out the area, and basically it will be half the length of AB, the length of AC, and then sine theta. The length of AB just now we already get the value, which is a 3. Okay, you can go back and recall. Right, so the modulus of AB is the length of AB, right? We get a 3, and then the length of AC we get a 5. So we are having 3 and 5 with sine theta. Okay, so what is the value for sine theta? So recall again for part number 2. For part number 2, the value for cos theta that we have is actually 1 over 3. So from here, we can draw a simple triangle, where this is a theta. Cos is 1 over 3 means that the adjacent length is 1 and then the hypotenuse is a 3. So we can get this length here, which is 3 square minus 1 square, and you will get square root 8. So we'll put it as square root 8 here. Alright, and now if I want to get the sine theta, refer to this particular triangle here. So sine theta will be square root 8 over 3. Okay, 3 and 3 can be simplified. And then for the square root 8 here, I can further simplify, become 2 square root 2. And then again, 2 and square root 2 can be further the 2 and the 2 can be simplified. Then multiply the 5 with the square root 2. My final answer will be 5 square root 2. Okay, so this is how we solve question number 6. Question number 7. We are having the differential equation with x and theta. Right, so this is the equation that we have, a differential equation. And then they are saying that the theta is from 0 until pi over 2, which is 90 degrees in the first quadrant. And then x greater than 0 means x is positive. It is given that x equals to 2, and then when the theta is equals to pi over 4. So first of all, we are going to show that this differentiation, for when we want to differentiate the cotangent square theta, we will get this fraction. Okay, and for this question here, they give us a hint actually. You can assume without proof that the derivative of cotangent theta with respect to theta is negative cosecant theta. So this sentence basically means we are having, if we want to differentiate cotangent theta with respect to theta, right, the answer should be negative cosecant square theta. Alright, so this is actually the result that you can use in our solution later when you want to show the result. Okay, so we will start. If I want to differentiate, right, cotangent square theta, basically it will look like cotangent theta and then square. When we want to differentiate something, a bracket with a power, the step will be pull the power in front. So I'm having a 2. Copy the bracket, which is cotangent theta, power minus 1. 2 minus 1 will become a 1. After that, you need to differentiate the thing inside the bracket. So now I want to differentiate cotangent theta. So like what the question mentioned earlier, if you differentiate cotangent theta, you have negative cosecant square theta. So I need to multiply with negative cosecant square theta. Alright, and now I need to further simplify all this to get the answer. We know that cosecant square theta is actually 1 over sine square. So if I want to change it become the denominator, I will have negative in front, and then cosecant square, it will become 1 over sine square, right? So this is basically how we get the answer. Okay, alright. And for this question, basically we are using the hint given by the question itself. For those who are not aware of the hint, right, you still can use maybe the quotient rule to apply in the differentiation. Of course, you need to further simplify it to get an answer. Right. So there are many ways, okay? But for this question, since they already give us the hint, so if you want to use the hint to solve, to prove, right, then this is basically how we show it. All right, so for those who are interested, actually you can try to use maybe some other method, such as quotient rule for differentiation, and simplify it. Eventually you will still get the same answer here. All right. Okay, then let's proceed to part number B. They want to solve the differential equation and find the value of x when theta is pi over 6. Okay, so first, of course, we need to solve the differential equation first. The original differential equation looks something like this. I'm having x and then sine square theta dx d theta. It is equals to tangent square theta minus 2 cotangent theta. Okay, so before I can move the d theta over, right, I want to group all the theta one side and then all the x one side. I think very obvious. On the left hand side, we only have x and dx. And for the right hand side here, I want to move all the theta go to the right hand side. Therefore, if I bring the sine square over the right hand side, I'm having this divided by sine square theta. Then for d theta, if I bring it over, I'm having a d theta at the back. So you can see now very clearly that we are actually having the variables separated to two different sides. So the left hand side, we are having all the variable x. For the right hand side, we are having all the variable theta. So once we separate the variable already, we can put the integration sign and we will proceed with the integration process. Right, so integrate the x, I'm having x squared over 2. For the right hand side, before we can integrate it, we might need to slowly simplify first. Tangent square theta divided by sine square theta. So I write it out like this first. And then I'm having negative 2 cotangent theta divided by sine square theta. Okay, so if we try to observe this particular fraction, right, we can't integrate straight away like this, but if we try to simplify it, such as sine tangent square theta can be written as sine square over cos square. This is tangent square, right? And then originally you're having sine square at the bottom at the denominator. So I'm having sine square here. Then from here you can see that we can actually simplify it. And then if we simplify the sine square with sine square, we still have 1 over cos square. And 1 over cos square can be written as secant square. So you can see that when we try to simplify this fraction, right, eventually we get a term or maybe we get an expression that can be integrated straight away later, because integrate secant square we are having tangent. Then now let us observe the second term here, 2 cotangent theta over sine square theta negative. This particular fraction appeared just now in part number 1. Okay, so you can see that this one, negative 2 cotangent theta divided by sine square theta. And we know that from original question cotangent square theta to this one is differentiation, right? This is differentiation. And by right, we actually know that if you want to integrate this term, going back, it should be integration. Okay? Which means that if I integrate this fraction, my answer for integration will be cotangent square theta. Okay, so we can actually solve both terms here already. Okay, so I just copy it again now. Integrate secant square, I will have tangent theta. Integrate this particular term, you are having negative cos cotangent square theta from the first part, part A. Sorry, because they want to have integration of negative, right? So maybe I need to assume that this is negative and then this is a plus, so that I integrate this whole sign here. By right, this one should be a plus, and then plus C. We need to find the value for C before we can continue further. From this question, it is given that x equals to 2 and then theta equals to pi over 4. If I try to substitute into my general solution here, we will have 2 equals to Tangent pi over 4 is a 1. Cotangent square theta, cotangent pi over 4 square, it is also a 1, then plus c. And we can see that c is equals to 0 basically. Okay, then if I try to rewrite my equation again, I'm having x squared over 2 equals to tangent theta, then plus cotangent square theta. Of course, there's no more plus c here, right? This is my particular solution. And for this question, after we solve the differential equation, they want us to find the value for x when theta is equals to pi over 6. So we should continue from here. Okay, so for this part, I want to remember it. Okay, I bring it to the next part here. Okay, if I want to get the value of x when theta is pi over 6, we have to substitute the value inside, right? Okay, so we'll start here. Okay, so now yeah, when theta is equals to pi over 6. Okay, when theta is equals to pi over 6, what's the value for x? First, we try to substitute all the data with pi over 6 first. And then try to press calculator to help us. So tangent pi over 6 will be 1 over square root 3. For those who are using MS calculator, then you might need to use the right angle triangle to help you. Okay, and when we are having this, which is pi over 6, 30 degree, I'm having 1, 2 square root 3 here. So if they're asking for tangent pi over 6, it will be 1 over square root 3. Right, then for the second term here, I'm having 1 over square root 3 squared. Okay, then if I try to simplify everything, okay, and multiply with 2, and then take square root, okay, I try to bring all the number here over to the right hand side and get the value for x. So after I have this answer, I need to multiply with 2. Okay, so I need to multiply with 2 and then I take square root. So if I multiply with 2 and take square root, my z will be a long value. And then of course we need to correct it to 3 significant figure where the answer for x should be 2.67. Okay, so basically this is how we solve question number 7. Question number 8, the diagram show parts of the curve y equals to sine square root x, and then this part of the curve intersect with x-axis at the point where x equals to a. So you can see that they label it quite clear. This is actually the value of a. So now they want to state the exact value of a. So to get the value of a, we need to let actually y equals to 0 because it is actually the x-intercept, right? So if I let y equals to 0, I'm having sine square root a. Okay, so sine inverse 0, I'll get the square root a here. And now we need to try to consider, alright, when sine inverse 0, there are many possible values. It can be a 0, it can be a pi, it can be 2 pi, it can be 3 pi, and so on. Alright, so definitely the answer is not a 0 because it is not on the origin. So 0 will be ignored, and then the second value, the possible value will be the pi, where it is possible. So if I am having square root a equals to pi, therefore my a will be equals to pi squared. So this is the answer for A. Okay. Then proceed to part number B. By using the substitution of u equals to square root x, they want us to find the exact area. So please highlight the word exact area. Your final answer should be in the third form, long form, but not the decimal number pattern, right? Of the shaded region in the first quadrant, bounded by this part of the curve and also the x-axis. So to get the area, basically we need to apply integration by part. Integration. You have to apply integration to find the area. And then for this question, they already give us a very obvious hint where we have to use the substitution method for the integration. So before we use any substitution method, let's set up the formula to find out the area first. Also, you can see that the area starts from 0 until pi squared, right? Okay, and then mainly it is bounded by the x-axis. Therefore, you integrate towards the x, right? And also the curve. So when I want to set the question here, the equation, the area will be actually equals to integrate from 0 until pi square. And then the function that we have here is sine square root x dx. Okay, so this question basically is, this equation basically is quite hard for us to integrate. We haven't learned how to integrate this pattern before, but they already give us a very clear hint where u is equals to square root x. So we should start from that. Okay, we are given u equals to square root x, right? Which is actually x power half. Okay, so first we need to try to find out the differentiation of u towards the x first. So du dx will be equals to half x power negative half, and it will look something like 1 over 2 square root x. And my du can be written as 1 over 2 square root x dx. From the x here, I will bring it over to the right hand side. This is the equation I had. And then I want to make my substitution easier later, right? I want to keep only the dx in my equation. So I bring out the 2 square root x to the other side. But if I want to express everything in terms of u for the left hand side, then I'm having 2u du equals to dx. How I know that 2 square root x become 2u? Because u is equals to square root x. Therefore, I replace it back, become the u variable in u, in terms of u, alright? And now we also need to consider the change of limit. So all the limit here are for the value of x. So when x is equals to pi square, what is the value of u? U equals to square root x. So square root pi square, u is equals to pi. And for the lower limit, we are having x equals to 0. When x equals to 0, what happened to the u? It will be square root 0 square. Square root 0, and of course we get a 0. So once we have all the limit, the change of limit, and also the change of the variable from x to u already, then we can start our substitution process. Okay, right, so first of all, we have to change the limit, become pi and 0. Sine x, I will change it, become sine u. Dx, I will get the result from here. Dx can be written as 2u du. Okay, and if we try to simplify it, I'm having 2. I prefer to bring the constant in front, and then we'll have u sine u du. And now if we have a look for u sine u du, right, it is actually two different types of function, and they are the product of two functions. So when you're having the product of two functions, for the integration part, usually we need to apply integration by part. Okay, so for integration by part, the general formula will be uv equals to, v du, u dv equals to uv minus v du. But because we are having the variable u here, right, so I would want to change my original equation for the integration by part to w. So that means originally, if I'm having w dv, it should be equals to wv minus v dw. Okay, so the w here will be, we can decide the w and dv, right, by looking at the category of our function here. So u basically is algebraic function, which is a, and then the sine u is trigo, t. Okay, so to decide the integration by part variable, right, we are having the rules, which is LIATE. The higher group will be the w, the lower group will be the dv. So I think it is very obvious. A is our higher group, right? Which means that I will let u equals to w, or w equals to u. Okay, and dw divided by, dw, I want to differentiate that, so dw over du will be equals to 1, and from here we get dw equals to du. okay? And then for the t here, it will be integrate dv equals to integration of sine u du. The remaining part in our equation is sine u du, right? Integrate dv, I get a v. Integrate sine u, I will have negative cos u. Alright, because our integration haven't completed yet, so I will not put a plus c here yet. Alright, and now I will start to apply the integration by part. I need a longer space, so maybe I will start here. Okay, so 2 is a constant I just copy, and I want to apply the integration by part formula. W is a u, v is this one. Therefore, we are having u multiplied with negative cos u. Then I have to substitute the limit pi and 0. Okay, then for minus part, I just put a minus. Then 2, I'm having a 2, right? Originally, I'm having a 2, so I should include a 2 here also. Then put in the limit 0 until pi. And now we are looking for v dw. So v is negative cos u. And the dw is actually equals to du. Alright, and now we try to substitute in the value. Substitute pi into the first equation here. I'm having negative pi. Cos pi. Cos pi, basically I get negative 1. Then minus, substitute 0 inside, I'm having the whole thing, which is a 0. For this part, I take the negative out, become positive 2, and I want to integrate cos u. Integrate cos u, I will get sine u basically, and then substitute the limit 0, pi and 0. Okay, simplify the term in front, I'm having 2 pi. Substitute pi into the u, I'm having sine pi. So sine pi, if you press calculator, you get a 0. Substitute 0 into the sine u, you get sine 0, which is a 0 as well. So the final answer for this integration of the area is actually 2 pi. Okay, so if you have a look for the question again, they're asking for exact area, therefore we should leave it in the pi form. Okay, so this is how we answer question. Question number 9. We are having a semicircle, diameter AB, and then the radius is R. The shaded region is the minor segment on the chord AC, and the area is 1/3 of the area of semicircle. Then the angle CAB is theta. They want us to show that theta equals to this equation. Okay, they want to get this equation. Right. Okay, so maybe before we start, there's one important information here where they are saying that the shaded region is the minor segment of chord AC, right? And the area for the chord or for the minor segment AC is actually 1/3 of the area of the semicircle. So this is the information that we should start with. Okay? And then before we start, maybe we need to find out all the possible angle first. So we should know that OA is actually the radius as well, because AB is the diameter, right? So this is actually the R, the radius. And then for this triangle, because both are radius, we are having the isosceles triangle. Therefore, this angle here should be a theta as well. And how about this angle AOC? So the angle AOC will be pi 180 degree, right? By using the rules in the triangle, the total angle should be 180 degree, which is a pi, then minus 2 theta. Alright, so first important information will be the angle AOC is actually pi minus 2 theta here. And I think later if you want to find all the angle, all the area should be no problem since we are having all the details here already. Okay, so we will start with this one. The area of the segment AC. Area of the segment, I will say this one, okay? It will be equals to what? 1/3 of the area of semicircle. So 1/3 of the area for semicircle. So this is how we start actually. So first of all, let us form the equation for the area of segment. So to get the area of segment, what we do is we try to take the sector formula, sector area minus the triangle area. Okay, so what is the sector area? Sector area will be half r square theta. So in this diagram, our theta is actually pi minus 2 theta. So I put in pi minus 2 theta equal then minus, I have to minus the triangle so that I can get a segment, right? So for triangle area also I'm using half AB sine C. So we are using the both length for radius half AB and then sine the angle here. So we'll have half AB, which is r squared, and then sine C, and the angle that we have is pi minus 2 theta equals to 1 over 3 the area of semicircle. For circle, the area is pi r squared. Semicircle will be half pi r squared. Okay, so this is the general formula that we can form from this equation. And then we can try to simplify all the possible terms that appear in this equation. We can simplify half r squared, and half r squared. And we'll get the left hand side, which is pi minus 2 theta, minus for sine pi minus 2 theta, right? When you are having pi minus 2 theta, basically it means it is something in the second quadrant. Now we assume that it is something in the second quadrant. When you are having sine pi minus 2 theta, right, the value should be the same for the answer in the first quadrant, where the basic angle is 2 theta, so it will be the same as sine 2 theta. This is in the second quadrant. This is in the first quadrant. In both second and first quadrant, right, both sides are having positive value. Okay, and then for the second quadrant, since you are having pi minus 2 theta, okay, the value is the same as the sine basic angle, which is the 2 theta. So this is actually equals to sine 2 theta. Therefore, in my solution here, I will want to substitute by using sine 2 theta equals to 1 over 3 pi. According to the equation that they want us to show, right, you can see that sine 2 theta should be on the other side. Then theta should be on one side. So what I'm going to do is that I want to move the negative 2 theta to the right hand side, then the pi over 3 to the left. And my answer will look something like this. So pi minus 1 over 3 pi minus sine 2 theta equals to 2 theta. Okay, so if I rewrite again, I'm having 2 theta equals to 2 over 3 pi, then minus sine 2 theta. Okay, so next step, I divide my whole equation with 2. According to the equation that they want us to show, right, I can see that they factorize out the 1 over 3. So if I factorize out the 1 over 3, then my right hand side will have pi. Multiply the 3 here, 3 divided by 2, I get 1.5, so sine 2 theta. So eventually we'll get this equation, theta equals to this. Alright, so the beginning part will be actually starting from the information that it gives us, where the area of segment is equals to the 1 over 3, the area of the semicircle. Then we slowly simplify and get this equation. Okay, and now let us proceed to part B. For part B, they want us to verify that the theta lies between 0.5 and also 0.7. For this question, I want to use the sign change method. Before the sign change method, right, this is my original equation that I have. And then if I want to get the sign change method, I have to move everything to one side, where I will make it become a function g. So g theta is equals to 1 over 3 pi minus 1.5 sine 2 theta, then minus theta. Okay, to prove that the theta lies between 0.5 and 0.7, then you should substitute first equation, okay, the equation on top, on this one with g 0.5, with 0.5, then another one will be to find out the value of g 0.7. Okay, by substituting inside the calculator, right, please take note that you have to make your calculator in the radian mode. Okay, Then when you press calculator for G 0.5, you'll get 0.126. When you substitute the value negative, 0.7, then you'll get negative 0.146. Okay, so you can see the sign change happen here. Alright, one is positive and one is negative. Therefore, you can make a simple conclusion where sign change can be seen between G 0.5 and also G 0.7. Okay, so this also concludes that the data lies between 0.5 and 0.7. Okay, so this is a simple conclusion that we can make. Alright, once you can see the sign change here, then basically it also helps us to conclude the data lies between 0.5 and also 0.7. Then we continue to part C. Okay, so for part C, they want us to use iteration formula based on the equation in part A. Okay, to determine data correct to 3 decimal places, and each iteration result should be in 5 decimal places. Okay, so we recall back what is the formula for part A. So we are having data equals to 1 over 3, and then pi, right? So pi minus 1.5 sine 2 theta. Okay, and we want to use this iteration formula to get the answer for the data. Okay, so what's the initial value that we should use? You can use any value that's between 0.5 to 0.7. You can start from 0.5, you can start from 0.6, 0.7. For me, I'm using the midpoint between 0.5 and 0.6. 0.7, I use the 0.6. Okay, so before I find out the value for 0.6, right, for theta 1, I want to substitute 0.6 into the iterative formula to get the theta 2, which means that to get the theta 2, I have to substitute into 1 over 3 and then pi minus 1.5 sine 2 times of theta. It will be 2 times of 0.6, which is 1.2. Alright, and we can actually use the calculator to help us to get the value. Alright, so let's try to key in the formula here. Okay, we are having pi minus 1.5, then sine 2 theta, it will be sine 2x. Okay, and divided by 3. This is my iteration formula. And since trigo function is included here, right, is involved here, therefore before my calculation, I have to change my calculator into radian mode first. So I press shift. Okay, so I make sure that it is in the radian mode, and I key in the iteration formula already. Okay, and now we will start calculating the value, right? So first we will press on the calculation sign, then key in the initial value, which is 0.6, and we press the equal sign. So from here we actually get 0.581178, and they are asking for 5 decimal places for the iteration result, right? So 5 decimal places will be 58118. So the first value that we are having is 0.58118. And of course, to get the third value for the theta, I will substitute 0.58118 into my iteration formula again. By the help of the calculator, I press calculate again, and then I will key in 0.58118 and press equal sign. And for now, I'm getting 0.58833, correct to 5 decimal places, 58833. And now, if I want to put it, I will have 0.58833. Okay, then I double check the 3 decimal answer here. They are not the same value yet. 0.581 and 0.588. Therefore, I have to continue the iteration until I get 3 decimal places with the same value. Alright, okay, so next one, I will want to calculate again. Then 0.588 0.58633 equal sign, then I get 0.58553. So 0.58553. Again, double check for the 3 decimal places, they are not repeated yet, then we continue the iteration. Okay, calculate 0.58553 equal sign. So it will become 58662. 0.58662. Again, still haven't repeated yet for the 3 decimal places answer. Continue one more time. Okay, calculate again. 0.58662 equal sign 58619. So 0.58619. Not repeated yet. Continue. Okay, 58619. It will become 58636. Alright, if you double check these two values here for 3 decimal places, right, they are actually both 0.568. Sorry, 586. If you want to double confirm again, then of course you can try to confirm by using one extra more iteration. Alright, so calculate 0.5858636, and I get 58629. Okay, so again, I think it is quite obvious already, because if I round it off to 3 decimal places, then I will have 0.586 as well, which means that this is actually my answer for the root. So I can write the root is actually equals to 0.586. Okay, so this is how we actually find out the roots by using iteration formula. Okay, when you want to show the answer for all the iteration, right, please make sure that you show everything in 5 decimal places. Okay, and the final answer for checking you try to check it by using 3 decimal places. If they are repeated, then this is your root. Okay, so this is how we solve question number 9. Okay, so we are now at the very last question, question number 10. They want us to express fx in partial fractions. Okay, so first of all, let us double check the degree of the fraction and see whether they are improper fraction or proper fraction. So for this one, we are having the highest power with a 2, so the degree is equals to 2. And then for the denominator, if we multiply them, they are x power 3, right? So the degree is a 3. So degree on top is less than degree at the bottom, therefore this is a proper fraction. So for proper fraction, we can straight away separate it into the partial fraction. Okay, so we try to observe the factor that we have, or maybe the denominator that we have. We are having one linear factor, which is 1 plus x, and we are having one quadratic factor, which is 2 plus x squared. So for the linear factor, we are having constant a on top. For the quadratic factor, we should have bx plus c on top. Okay, multiply the whole equation with the denominator on the left hand side, so that all the denominator can be cancelled off. So I'm having 4 minus x plus x squared equals to 1 plus x cancel off with 1 plus x, therefore a is multiplying with 2 plus x squared. Bx plus c have to be multiplying with 1 plus x because the 2 plus x squared has been cancelled off. Alright, so to find out the constant value for a, b, and c, I will use the eliminate the unwanted unknown. So first of all, I will refer to the first bracket here, which is 1 plus x. I will let x equals to negative 1. If I let x equals to negative 1, substitute negative 1 into my left hand side here, I will get a 6. Substitute negative 1 into this part, I'm having 3a, and from here I'll get a equals to 2. Alright, so why is it 3a on the right hand side only? Because of if I substitute negative 1 here, the whole thing for bx plus c multiply with 0 and they disappear. So very easily I can get a value for a. Then after that, I need to find the second value so that I can find some other constant here. Maybe I will let x equals to 0. When I let x equals to 0, b will disappear, right? Okay, so I will let x equals to 0 for this second value. Substitute into the equation here. So 4 minus 0 plus 0, I get a 4. Then I have 2 plus 0a, which is 2a lah. So 2 times 2 is a 4. Because a you already get a 2 just now. So 2 times 2 is a 4. 0b plus c. So you're still having the c. And then multiply with 1 plus 0, which is a 1. From here, you can see that the value of c should be equals to 0. And after I found the value for a and c already, there's no more linear factor that I can use again. So I can let x equals to any value that I had never used before. So maybe for me, I'm using 1 here. So I will let x equals to 1. Substitute into this equation, the left-hand side of the expression on the left. So I'm having 4 minus 1 plus 1, which is a 4 also. And then 2 plus 1, I get a 3. 3 times a, which is a 2. So 3 times 2, I get a 6. 1 times b, I get a b. C is a 0, that's nothing. 1 plus 1, I get a 2. So b multiplied with 2 here. And if I try to simplify it, my b is equals to negative 1. Okay, so seems like we already find out all the value for a, b, and c. So usually for me, I will just write out the answer again, where it should be 4 minus x plus x squared divided by 1 plus x, and then 2 plus x squared, which is equals to 2 over 1 plus x, then negative x over x plus 2 plus x squared. There's no c, right? So c is 0. Therefore, my partial fraction will look something like this. Okay, so this is how we get the partial fraction for part number 1. And now let's proceed to part number 2. Okay, so for part number 2, they want us to apply integration. So I just want to recall back my result here. Okay, I'll bring it out first. Okay, so this is my result in part A. Okay, so they want to find the exact value of the integration. For this one, give your answer as single logarithm. Okay, so that means if I want to integrate 40 for function fx, I will want to use the partial fraction result, which is 2 over 1 plus x minus 2 over 2 plus x squared, and then dx. Okay, so for the first term, it's very easy for me to integrate. I'm having 2 ln 1 plus x. And of course, I have to substitute the limit, which is 4 and 0. And for the second term here, we actually need to rephrase our equation a little bit, or our expression a little bit, so that I want to change it become f prime x over fx pattern. If I try to differentiate 2 plus x squared, this is fx, and then for f prime x will be 2x. That means my numerator, I should have 2x on top. But since now I only have x, therefore I can adjust my expression by multiplying a 2 inside. But of course, at the same time, I need to divide another 2 so that they balance up each other. Okay? When I write it out in the proper step, then it will look something like this. I'm having negative still, right? So I'm having 0 and 4. Originally, I'm having x over 2 plus x squared. Because I want to have a 2 inside, so I multiply the 2 inside the x, and outside I divided it by 2. So that when I'm having this part, right, this is actually my f prime x, and the denominator here will be fx. So I have to integrate, I will integrate the f prime x over fx pattern for the integration technique, alright? Yeah, so, okay, so we should continue from here, right? Okay, maybe I substitute all the value in first. So substitute 4 into the x, I'm having 2 ln 5. Substitute 0 into the x, I'm having minus 2 ln 1. Okay, so the negative half I just copy. Since I'm having the f prime x over x pattern, therefore I will have ln, and then 2 plus x squared, and I want to substitute the limit 4 and 0. Okay, so I just copy 2 ln 5 first. 2 ln 1, ln 1 is a 0 lah. Therefore, I will not write it out anymore. This is a 0. And then negative half. I start to put in all the value here. So 4 squared is 16. 16 plus 2, I will have ln 18. Substitute 0 inside, I left only ln 2. Okay, since they want us to have our answer in single logarithm, right, I have to bring all the number in front, the ln, go back to the back so that it becomes the power. Okay, for this one I'm having 5 squared, so 5 squared I'll have 25. Then negative half I just copy first. Ln 18 divided by 2, I will simplify, become ln 18 divided by 2, where we are having the property of the ln, right? So ln A over B can be written as ln A minus ln B. So we are doing it backward now. Alright, we are doing it backward. Okay, then after that, what do I have here? So I'm having ln 25. Then minus, we are having ln 9, right? And I pull back the square root, the half over become square root 9. Okay, so become ln 25 minus ln 3. Then again, I apply this rule one more time, going backward again. So I will have ln 25 over 3 because of divide, right? So I'm having ln 25 over 3. And you can see that our answer here in a single log form. Okay, right, so we have finished discussing all the questions in this paper. So thank you very much for watching.